Hey guys, alright, so today I'm going to be telling y'all about how to do the derivative of natural logs. So starting off, this is a pretty simple thing. The derivative of the natural log of x is going to be u prime over u, and the x right there, anything that is in there, that's always going to be what your u is. So here we would have the derivative of x, which would be 1 over u, which is x, so 1 over x, and that would be what that is. So a lot of times you'll see the derivative of the natural log either written as u prime over u, or down here, this is going to be another way that you might see it written. It's going to be the derivative with respect to x of the natural log of a f of x, so if it's something a little bit more complicated than an x, it'll be 1 over f of x times f prime of x, which is going to be the same thing as u prime over u, because you can just multiply the numerators across. So that's going to be the basis of taking the derivatives of them. So now, to get into the examples, we will start with this one. So this is a pretty simple one. We have f of x equals the natural log of x squared plus 10. So taking the derivative of that whole inside function, which is u, it's just going to be 2x over u, which is the whole thing inside the parentheses. So it's going to be 2x over x squared plus 10. So as you can see so far, they're really simple. They don't take that much. Down here is going to be one that's a little bit more tricky. It's like the place where these types of problems are going to trick you up is going to be the combination of other tools and stuff with it, such as this one here. So here we have f of x equals the square root of x times the natural log of x. So if you were to look at it, you might get confused and take the derivative of the whole thing, but you have to go back to your previous knowledge and know that you would need to use a product rule for this. So that's exactly what I did here. So separated into f and g, so I made f my root x, which I just rewrote as x to the 1/2, and then my g is that second function, which is the natural log of x. So we have f prime using the product rule. You have equals 1/2 x to the negative 1/2, and then here for the g prime, just imagine that that's g prime. You're going to have to use the u prime over u again, which would just be the derivative of x, which is 1 over x. So you do that, and then multiply across, so cross multiply. Yeah, the square root of x over x plus 1/2 x to the negative 1/2 all times the natural log of x. So unlike this problem, in this one you are going to have the natural log of x in your answer, even though that's something that you were taking the derivative of. And that's just due to using the product rule. So that's a way that it can trick you up. Just go back over your work, double check that you did everything right for that. Alright, and then coming over here into the final one, this is going to be kind of the most complicated one, or one of the trickier ones that you would see for taking the derivative of the natural logs. And that's because you have to combine a lot of previous knowledge, and that's places where you can get messed up. So we have f of x equals the natural log of 2x plus 1 all cubed over 3x minus 1 to the 4th. So keeping in mind the log rules, you know that you can subtract those, which is what I did in this next step right here. I just took the numerator, times it by the natural log, and then subtracted it. And then once again, using rules, you know that you can bring those exponents down. So I brought the 3 over to the front, and then here I brought the 4 to the front. So now, the only thing that I've done at this point is just simplify using previous knowledge, and so this is what I'm going to be working with now. So now that I have two separate things and they're being subtracted, I'm going to solve each one individually, and then go from there. So here you're going to have 3 because of the front, and that's why we have the 3 times the derivative of this inside function, which is your u, which is going to be 2 over the original u, so over 2x plus 1. And then minus, and that's minusing because you're dividing. 4, which we have the 4 pulled out here, 4 times the derivative of this inside function u, 3 over 3x minus 1. So go ahead and simplify from there. And normally this would be a good stopping point. You could go ahead and get them all over one, get them all like combined, but that's not necessary. This is pretty simplified enough. Yeah, so some things just to remember is it's always going to be u prime over u. Don't ever get that confused. And then just always be careful that you're looking out for whenever they're being combined with other things such as product rule, quotient rule, and then don't forget that you can simplify things using your log rules, and that's going to make taking the derivative a lot easier, or else you can end up with a super messy answer. So I hope that you learned how to take the derivative of natural log functions, and yeah.